हाँ जा
हाँ रिकॉर्डिंग
ठीक है ओके
स्टार्टेड।
ओके ओके so we'll start our remaining part of the second chapter. So before starting the uh, whatever remaining part of the second chapter, so we'll just recap the whatever we have covered in the this second chapter, that is the computer graphics and geometric modeling. Okay, so we have seen that in the first part of the second chapter, that is the computer graphics, in that we have seen that the various graphics transformation techniques. In that we have seen that there are total 5 types of the translation. So we will just see one by one. This is the geometric transformation forms. These are the simple formulas for the simple geometric transformation formulas operation, where we are going to using only a single operation for a single problem. Okay, so just you have to remember that whenever you are going to solving the problem, in that problem, suppose there is only one condition, means only one operation is there, suppose like translation, rotation, and at that they are placed at the origin, so we have to use the simple geometric transformation formulas. Okay, so for that purpose we have seen that the geometric transformation matrices for the these 5 conditions. Okay, so this is the simple geometric transformations formulas regarding the translation, rotation, scaling, shear, reflection, mirror. Okay, so we have seen that the simple problems on that. You got the some idea about the how to solve the simple geometric problems. Then second title we have seen that the homogeneous coordinate transformation. Okay, so what we have seen in previous geometric transformation formula, in that we are going to consider only simple problem, means at a single problem a single operation. But suppose in computer graphics we have to do more than two or more than one operation at a single point, so we have to use homogeneous coordinate transformation system. Okay, the same transformation technique is there, just whatever matrices is there for different conditions, that will be modified in terms of the new formulas. Okay, so we have seen this for point P we can write the matrix like this, for line, for triangle. Okay, so this is some examples related to homogeneous, how we are going to formulate or write a matrix for a particular homogeneous transformation system, where we are going to do the more than two or more than one operation at a single problem. So we will see some matrix formula for the translation, rotation, scaling, mirror, and shear. Okay, like this we are going to using different matrices, different formulas at a single problem in computer graphics. So already we have seen a simple problem regarding the homogeneous matrix. So next type, that is a windowing and viewing transformation. We have seen that the whatever that interested part is there, we are going to only focus on that interested parts. So for that we are going to using windowing and viewing command. So next we have seen that the coordinate transformation. So whatever that system is there, we are going to drawing in local or global. So suppose we want to transfer that system into a global system, local to global or global to local, that time we have to use this coordinate transformation. Then standardization graphic system, with standardization, without standardization. Then what are the basic functions or basic need for that standardization. Then various graphic standard like GKS, PHIGS, IGS, step. So in that we have seen that the IGS is one of the most widely used format for the current CAD/CAM CS system. Then next important part of the first part, that is the CAD/CAM data exchange. We are going to exchange data with the help of the direct translator and indirect translator. So in that we have seen that the what are the advantages of the like two type of the CAD exchange. Then what are the application of this geometric transformations. Then advantages, some objective questions from this third part. Then in last lecture we have seen that the introduction part of the geometric modeling. What is mean by geometric modeling? Their types: wireframe model, surface model, and solid model. And from these three, we have seen that the difference between these three geometric modeling, and what are the surfaces, their advantages, how we are going to use these three different parameters, and at a time of the modeling. So basically we have seen that the difference between these three modeling with the basis on this 12 parameters. So it will be easy for understanding the difference between these three modeling. Next, we have seen that the different representation schemes for the solid modeling. For that CSG, boundary representation, cell composition, then occupancy enumeration, then sweeping, then primitive. Like this, we have seen that the different geometric schemes for the solid modeling. So, what are the remaining part of this second chapter? We'll start from the parametric equation. Okay. So, next point is our today lecture, that is the types of the curves. Okay. Uh, One thing I want to clear here. In between lecture, I will ask question to anybody. Okay. So, uh, be ready for that and be listen carefully. Okay. Don't leave the meeting in between the lecture. Okay. So, first point, that is the types of the curves. Okay. So, there are two important types of the curve, that is the first is analytic curve and second is synthetic curve. Okay, so in that analytic curve, example like a point, line, arc, whatever we are going to draw a modeling or a part at a time of the modeling. So whatever that we are using the different type of the curve, simple curve, that is called as your analytical curve. And whatever that synthetic curve means, we are going to using whatever that input data, from that input data we are going to draw the curve, that is called as a synthetic curve, or we can call it as a free curves. We can, what we can call as a free curves means we are going to manage that the profile of the curve by using the local control point and global control point. So that's why they are calling as a synthetic curve, either free curves. Okay. So in that we can see two types, interpolation and approximation. Okay. An example for that, we are going to see Bezier curve, B-spline curve, and nerves. Okay. That is national curves. Uh, then based upon the dependency and determination of the coordinates, we are going to see two important part as a non-parametric curve and parametric curve. Again, in that non-parametric, we are going to see explicit form and implicit form. So right now for you, this is not important to know about the how we are going to calculate the explicit and implicit form. For your information and for your understanding purpose, we are going to just, I'm going to just tell you the what is meaning of the non-parametric and parametric curve. We have to just study just a Bezier curve, B-spline curve, and nerves curve. Okay, whatever that simple type of a curve is there. In university exam, they are not going to asking the please explain the non-parametric curve and parametric curve. Okay, so this is one of the type of the just curve where we are going to just, with the help of this different curve, we are going to drawing the model. Okay, second is a parametric, in that we can see x is a function of the u and y is a g of u. Here xyz is the curve defined in terms of the independent variable of the u. Okay, so we will see one by one curve. First is analytic curve. Okay, so basically in that curve we are going to supply input which is a standard for a mathematical calculation, and you can just if you remember the line equation, y is equal to mx. This is the standard equation for the line. So from this equation we can easily draw the a line and then circle x square plus y square is equal to r square. Okay, if you know the x and y coordinate and the radius, then you can easily draw the a circle. Okay, in the analytic curve. So these are the some standard example, these are the some standard formula for the given condition. So with the help of these standard formulas, we are going to draw the this curve. Okay, so these basic entities can be combined together with end condition and so as generate the overall curve the design. Okay, next is the synthetic curve. Okay, so in that the fitting of the curve which passes through the given data points and control points. Okay, whatever that given data of that particular model, that point we can call as a control point. Okay, and whatever that point, we have to first we have to draw that point on the graphs, and we have to follow the that path, and we have to passes through the that given data. So that will be create some type of the curve. We will see in later there are different types of the curve, how we are going to manage that. nature of the curve, okay, and its degree of freedom. So we will see in details. Then what are the application of the synthetic curve in design requirements of the mechanical parts such as the car bodies, aeroplane wings, ship hull, blades, bottle shape, biomedical applications. Now you can see a synthetic curve is widely used in our industry. You can see on the bonnet curve, whatever that example, we can take example of the four-wheeler car. In front of the first part, that is the bonnet. Now that manufacturing of that bonnet part, at that time there are n number of the curves, and we are creating a curve for the aesthetic look and your that aerodynamic flow. For that we have to create the some curves at the starting stage and at the age, okay. So that purpose we are going to use this synthetic curve for in automotive industries, aeroplane industry also, bottle shape, and there is a lot of medical application in that curve is present, okay. So for that we are going to use this interpolation and approximation type of the synthetic curve. So uh, now you can see in that first interpolation type, there is a four, five control point, that is a P0, P1, P2, P3, P4. Okay. And whatever that all 5 points, I am trying to cover all control points. I am drawing the control curve from the all the points. Okay. In the interpolation and in the approximation type, now you can see there are actually 5 points, but my curve is passing through only 2 points. Okay. So by this P1, P2, and P3 control point, you can control the nature of the curve. You can drag this curve to that P1 point, P3 point, and P3 point. And from this, you can modify it, or you can change the nature of that curve. Okay. So this is about the synthetic curve. So from this you can easily understand the nature of the curve and what is the application of the particular curve. So that is a important part of the synthetic curve, and how we are going to using the different type of the curve, that will depend on your design and model accuracy. Okay. Then now you can see there are some characteristics of this curve, synthetic curve. So first of all, that is a control points, then local and global control, then flexibility and order of continuity. Now you can see whatever I have said in previous, like this control points means whatever given data in terms of the coordinates. Suppose point 1 is having a 2 comma 1, that is your first control point, that is a p0, which is having coordinate something. So like this, whatever given data in terms of the 4 points, 5 point, like this is called as control points. Then from that control point, here you can see we are going to joining these 2 points. Okay. Suppose I will take one example. Okay, so first of all, I will take the control point P0, then P1, then P2, then P3, and P4. Okay, so this is our your different point P0, P1, P2, P3, and P4. Okay, in that interpolation, I have to draw the curve from this all point. Okay, so that interpolation is passing through this all the control points. And second thing, that is our second type. So in that same point, P0, P1, P2, P3, and P4. Okay. Basically, that curve is just taking the only 2 points at the initial level. Suppose you can consider, and suppose then after that I want to change the nature of this curve. So by using this control point P1 and P3, it is easy to change the nature of the curve. So by using just this control point, you can just drag this nature of the curve to the your required direction. So my next curve will like this. Okay. I am going to just drag this curve to this direction. Okay. By using this local and global control, you can easily change the or manage the nature of the curve. Okay. So that is not a difficult task. So these are the some characteristics of the synthetic curve. You can just manage local and global control of the curve. Then it will be provide a greater flexibility, and it order of the continuity will be depend of that the curve condition. Okay, so now you can see here there is a order of continuity chart is there. Suppose that curve is having order 1 degree 0, so that will be curve, two curves meet which form a sharp corner. Okay, so I will show you example with terms of the uh, graph. First of all, just I will show, if first order continuity, second order means, then we will get a linear chart. Okay, so that two tangent at a point of intersection, that time we will get some linear nature of the curve. And if like this order of continuity will get increases, then our curvature nature also increases. We will get a softness curvature. Okay, so I will show how. First, the zero order means a curve first C1 and curve 2 C2 meet at this point. That point you will get a sharp edges. Okay, not soft edges. Then second, if your order increases to the up to first order continuity level, now you can see C1 curve and C2 curve get a tangent at a linear manner. Okay, and later the order increased a second, so we will get a smooth curve by using this C1 and C2. Okay, so like this your order of continuity get increased, then you will get a smooth curve. Okay, just remember this one thing: if you are going to increase your order of continuity, then you will get a smooth curve. Okay, so next, that is the first curve, uh, Hermantide, that is a cubic splines. You can call it as a cubic spline. So major CAD/CAM software provides a three types and B spline curve, and the cubic spline passes through the data points, and Bezier and B spline curve in general approximate the data points, that is they do not pass through the all of the points. Okay. So in this Hermantide cube means you can call as a cubic curve also, cubic spline. So Hermantide curve is fitted to a set of the data points, means a curve passes through the data points and the tangent as the start and the end point. It expresses the shape of the Hermantide curve, and it is also called as cubic spline curve. Okay. So now you can observe there are 4 points. Okay, actually 2 points, means you can just draw with the increased order of the continuity. So now you can see I will just draw a new sheet. Suppose I'm going to draw a new curve, like this is your P0, P1, P2, P3, and P4. So first point is we have to join this all point with the help of this curve. Okay. So this is your nature of the curve of the Hermantide, whatever given data points, and from that data point we have to draw the whatever the sentence from the Hermantide. Requirement of the Hermantide is whatever the start point of this curve, which is actually tangent of that curve, and whatever the end point of this curve, that should also tangent to that curve. Okay, so whatever that I am going to draw a tangent here, that line makes tangent at this point P1, and last here P3 tangent. Okay, like this you can draw anywhere whatever that requirement. So that line should make a tangent to that curve. Okay, so that is the requirement of this Hermantide. And the basic difference of this remaining curve, so from that curve we can just add order of the continuity for the better surface finish, that is the smoothness of the curve. So it is the one of the simplest curve method in the this cubic degree, and this cubic spline curve passes to the data points, and there it will Interpolate means you have to pass the all the control points. Okay, so this is the first order continuity, and the general non-parametric equation for the basic 2D cubic spline is y is equal to a0, that is constant, plus a1 into x plus a2 x square plus a3 x square. This is the just increasing order continuity equations. If you are increasing the control points, then you will get the more number of the constant and equations. Okay, so this is about the first, the Hermantine cubic curve, and it is having some key features, like it is a parametric cubic curve. It can generate a long curve by combining the number of the curves, but it can provide only C0 continuity. Okay, and it is the interpolation type of the curve, and hence it is not used to generate free from the shape. Okay, it is having interpolation types, so it is having some drawbacks. So it is, we cannot use to generate free from space. Okay, and 2 points and 2 slopes at the start and the end points are used to input. Whatever that the starting point, which is going to, we are creating the tangent at the point. So from that we can create the slopes for first 2 points at the start as well as the at the end points. And the define the tangent is not very convenient. Okay. So from this curve, it is a basic curve of this synthetic curve, so it will be quite difficult to create the tangent, so it is not referred for create the tangent at the curve. Some drawback of the this Hermantine curve, due to its global control characteristics, by changing the position of the data points, entire shape will be changed. Okay, means suppose I want to change the shape of the curve. If once I am going to using the control point for changing the curve, so whatever the original shape of the curve, that will be changed. Okay, so this is the drawback. Then curve is always cubic regardless of the number of the data points. Then curve is less smoother than the other synthetic curve. Whatever that other synthetic curve type is there, regarding them, this type is not smoother than the other curves. Okay, so practically the direction and magnitude of the tangent is very difficult to know. So it is only about the some specific points. So it is not from this curve we are not getting a smooth curve, and we are not getting a directional magnitude. Okay, so so there, for this type of the curve, some more drawback is there. So we have to remove this drawback, so we will introduce the new type of the curve, that is the Bezier curve. Okay, so in that Bezier curve, we have to use the approximation values to produce the smooth curve and do not pass through the all the data points. Okay, so we are just removing the what are the drawbacks in the previous curve. There is a Hermantine curve. We are using the some approximation techniques in this Bezier curve, and we are going to making the smooth curve, and that curve should not pass through the all the data points, and influenced by the control points. The order of the curve is dependent on the number of the control points. Whatever that control point is there, so order is dependent on the that control point only. Okay, so I will show you how to draw. Now you can see here, suppose first I will draw this control point P0, P1, P2, and P3 and P4. Okay, so this is the initial control point where we are going to join this all control point. Okay, so this is the initial nature, but this technique we are going using in Hermantine curve. But in Bezier curve we are not passing going to use the all the control points. So whatever that curve is passing through only these 2 points. Okay, so depend on that approximation techniques in Bezier curve, the condition is there, we don't have to follow the all the control points. Okay, whatever that requirement shape is there, from that requirement we are going to just taking the requirement point. So whatever that starting point and end point, we are using this 2 point only, and we are going to create the a smooth curve. Okay, instead of going the second point, third point, and fourth point. This is first condition. Then second condition, then again this we are going to show the how that nature is going to change of the curve. So P0, P1, P2, and P3. Okay. So this is initial nature of the curve, whatever that previous techniques, Hermite curve, and whatever that new technique that is your Bezier curve, we are going to follow in the approximation techniques. Okay. This is your P0 point, this is your P1 point, this is your P2 point, and your P3 point. Okay. So this is the displacement at the P0 point, U0, and U is equal to 1 at the last point. And this is the direction of the displacement. So this is the given data. Suppose I want to change, I want to cover the P1 and P2 point, but I don't want to change of the nature of the curve. So we can just drag this point to the required condition. This is your initial curve. Okay. Suppose I want to change the, I want to cover all the point, but I don't want to change the nature and shape of the curve. So I will cover all the points. This is the second condition. And for this, there this curve is having some properties like this some features like curve passes through P0 and Pn means n number of the point. So it we substitute u is equal to 0 as a displacement at the initial point is equal to 0 and displacement at end point is equal to 1. We are considering this nomenclature. So second, curve is a tangent to the first and last segment of the polygon. This is the uh, main condition of the synthetic curve. In first, there is a Hermite curve also here also. So curve is a tangent to the first and last segment. Then the curve shape can be modified by either changing or vertices. You can change the nature of the curve by using the changing the vertices as well as the just controlling the control points in the change the nature of the curve. Okay. You can your choice. You can just use the control points and you can just change the vertices. Then next, the curve closed Bezier curve can simply be generated by closing with polygon and closing the P0 and Pn to be considered. Okay. Suppose if you want to create the closed profile, then you can just close the P0 and Pn point. You can create the closed profile. Then curve lacks of the control local control point. Okay. So in this Bezier curve, there is a lack of the local control point. Okay. Whatever that control point is there, that is the P0, P1, P2 like this, that point is called as a control point. So in this type, sometimes they are losing the control of the that control points. So this is the drawback of this curve. Then if control point is moved, the entire curve moves. Okay. Suppose I want to move the one of the control point, then along with that control point, the curve will be also move the a new place. So that is one of the drawback of the curve. Okay. First, lack of the control does not passes all control point. Degree depends on the control points, and complicated shapes is required high order curves. So these are the some drawback of this Bezier curve. So whatever drawbacks from the Hermite curve we are overcome to in this Bezier curve, and whatever the drawbacks comes in Bezier curve, we are overcoming in the B-spline curve. Okay. So B-spline is a generalized form of the Bezier curve. It is just a modification in this Bezier curve, so we will get the B-spline curve and have ability to control the curve shape. B-spline also provide a possibility to add control points and without increasing the degree of the curve. We will get a smooth curve without increasing a degree of curve. Okay, so that is also important. And two kinds of the B-spline curve can be fitted a set of the data points. Okay, so we will see one by one in local control. So in that B-spline, there are some properties like this. The local control of the curve can be achieved by the changing of the position of the control point. In previous Bezier curve, there is a lack of the control point. So in this B-spline curve, we will get a better local control over the curve as compared to the previous curve. So multiple control points produce a high curvature. If you are going to increasing the control point, so it will be create or increase the higher curvature of that particular curve. Then increasing the degree of the curve makes more difficult to control. If you are going to increase the degree of the curve, so it will be create a problem for the degree of the curvature. So next part of the types of the curve, and that is a widely used in current CAD/CAM CE industry. That is a nerves. That is a non-uniform rational B-spline curve. Okay, so that is a latest type of the curve. So it is a mathematical model commonly used in computer graphics for generation and representation of the curve and surfaces. Okay, so this is the commonly used generation of the representation for the curve and surfaces types. Rational B-spline provides a single precise mathematical form capable of the representing the common analytical shapes like line, planes, conic, curvic, circle. Like this, it is used for the presenting this type of the shapes. Nerves are the superset of the all synthetic. Okay, it is one of the widely used curve in the CAD/CAM CE system, and it is superset of all the synthetic curve type. Okay, and it is suited for the creating organic smooth curve. So we will see, uh, and basically it offers a great flexibility as compared to previous all the type of the curve, and precision for handling both analytical and modeled shapes, and it is commonly used in for the CAD/CAM CE system. There are some different properties in nerves. So first, it can handle both analytic and synthetic curve. Okay, this is the one of the unique type of the curve where this a single type of the curve is a handle both analytical and synthetic curve. Some information of the simple shape may be lost due to the conversion into rational curve. Suppose if you want to just translate information of this non-rational to rational, though at that time some information may be lost. Okay, so using some control points, different curves can be generated. Using same control point, you can change the nature of the curve and you will get the new shape. Okay, in this nerves. So there are some advantages of this nerves curve, like it has more versatile modification capacity as compared to previous one. It can exactly represent the circle, ellipse, parabola, hyperbola. Okay, nerves curve exactly shows the shape of the circle, ellipse, parabola as compared to previous curve. Okay, in previous curve you can not exactly show like the circle. You can take the example of the circle, but it is not exactly look like circle, but in that nerves curve it will be show exact circle by using this type of the curve. So it is a modification of the, or it is just a representation of the superset of the all the synthetic curve. It can handle both analytical and synthetic curve. So that is the most important advantages of this curve over the all the curves. So this is the last type of the curve, and I want to just explain some basic parametric representation of the basic entities. Okay, so I will switch to Jamboard, so it will be better for explaining parametric representation. Parametric representation. So first of all, I will take as example of the line. So what are the parametric representation of the line? So in that there are two types. One of these implicit form and second is a parametric form. First, implicit form of the line, that is y is equal to mx plus c, and parametric form is like this: x is equal to a suffix x u plus bx. Like this we can write for y is equal to AYU plus BY. Okay, like this, these are the some implicit and parametric representation of the line. Then now you can just go for the second circle, how we are going to represent the circle in implicit form, like x square plus y square is equal to r square. This is your implicit form. And second parametric, like this, x is equal to r cos theta, y is equal to r sin theta. So this is your parametric representation of the circle. Third one, for ellipse. So what are the implicit form for the this first ellipse? So x square divided by a square plus y square divided by b square is equal to 1. This is the implicit form of the ellipse. And next, that is a parametric, that is x is equal to a cos theta, y is equal to b sin theta. So this is parametric representation of the ellipse. So like this, in our CAD/CAM computer graphics, we are going to using a different type of the representation in terms of the line, circle, ellipse, whatever that parabola, like rectangle. In terms of, we are going to using different formulas for different conditions. At the time of the drawing, we have to use different types of the curves. In that, nerves is one of the advanced techniques to creating the to handle the two types, that is analytic and synthetic curve at a single curve. So that will be produce a smooth type of the curve. So that is the useful, and that is the latest curve used in your CAD/CAM system. So this is about our graphical, that is a parametric representation of the some entities like line, circle, ellipse, and whatever that types of the curve is there in that Hermantide curve, B-spline, Bezier, and last one, that is a nerves, which is a, one of the widely used in your CAD/CAM system. Okay, so I think our second chapter is over. So we'll just see, recap or some objective type questions. Roll number 51, Mohit. Hello, hello, Mohit. If you are not giving a response, then I will write as your absentee. Okay. Roll number 51, absent. Yes. Uh, 51. Just tell me the first answer. The points that
Yes, sir.
govern the shape of the curve is modeling are called as control points, origins, end points, and set points. Answer is hello.
Control.
Okay, correct. So first is control points. Okay, we are going to using the control
First on
points, and
control point.
from that control points, we are going to create the shape of the that curve by using the control point. Second, roll number 22, Abhijit. Hello. Yes. Second question, a verification of interference of the features of objects in modeling is easily possible in which modeling? Wireframe, surface, and solid, and last is all of this. Verification of interference of features of object means assembly. Okay, whatever that assembly verification feature of that particular modeling is easy in which? Wireframe, surface, and solid.
All of
I
this.
think you are not getting the things regarding the modeling. In wireframe modeling, we are going to create only structural part of this that part. In surface modeling, we are going to create only surfaces. And last, in solid modeling, we are going to create all the internal properties as well as the external properties of the that part. And in that solid modeling, it is a uh, allowed to just interference second or other object that with the help of this the assembly. So answer is solid modeling. Okay.
Oh, yes.
Then next, roll number 8. Roll number 8. Hello.
Yes, sir.
Question number third. Which of the following is a type of the curve in a geometric modeling? Whatever that we have studied in previous 10 minutes, there are the how many types of the curve is there? We have seen just tell me the names of the curves.
Cubic curve,
Yes. Second.
B spline,
Yes. Third.
Bezier curve,
Then last one is nerves curve. So question is which of the following is a type of the curve in geometric modeling? First option is Bezier, second Benazir, third nerves, and D is both A and C. Which is correct answer? हॅलो.
हा सर.
हा आन्सर कोणतं बरोबर आहे याच्यात?
फर्स्ट.
आता तुम्ही मला टाईप सांगितले कर्वचे बेझियर, क्युबिक, बी स्प्लाइन, नर्व्स. मग याच्यामध्ये ऑड शब्द कुठला आहे? सेकंड ऑप्शन आपण शिकलोय का? बेनझीर.
नाही नाही.
हा मग आन्सर काय बरोबर आहे?
बी.
डी बोथ ए अँड सी. ओके. सो रोल नंबर 24 लोंडे. हॅलो. लोंडे इज देयर? वैभव लोंडे? Absent. 24 absent. Next. भंडारे 59. प्रणव. प्रणव. हॅलो. अनिकेत सरावळे 43.
हा येस सर.
हा कधी आला मीटिंग मध्ये?
थोडा वेळ झाला सर.
Okay. Can I ask one question? Hmm?
विचारा की विचारा.
आपण काय शिकलो सांगता का मला 2 शब्दात आजच्या लेक्चर मध्ये? आपण आज कोणते कोणते पॉइंट शिकलो ते फक्त मला सांगा 2 शब्दात.
कर्व चालू होते.
हा कर्व टाइप्स. Then
कंट्रोल.
it is one of the type of the curve. Okay. So just tell me the what points we have covered in this today's lecture. अविनाश लोंडे. Avinash?
येस सर.
Whatever we have covered in today's lecture points, you can just summarize.
समराइज
With 2 or 3
curves
words.
and curves and their nature.
Before that curve, you have present for the last 2 lectures.
Oh no sir.
Then I will ask one question. Which one of the following takes comparatively less memory space to represent objects in geometric modeling? Solid, surface, or wireframe, or none of this? कोणत्या मॉडेलिंग टाइप मध्ये मेमरी स्पेस कमी लागतो? सॉलिड, वायरफ्रेम का सरफेस? You have present na in last lecture?
No sir, last lecture I'm not.
Then what is the problem? Why you are not attending the lecture? अमन मुलानी.
हाँ सर.
हाँ लेक्चर करताय का
हॅलो.
अटेंड? यस.
2 झालेत.
ठीक आहे, मला आन्सर सांगू शकता का याचं?
हॅलो.
आता विचारलेल्या क्वेश्चनचा आन्सर सांगू शकता का? ठीक आहे, तर वायर फ्रेम मॉडेल मध्ये सगळ्यात कमी मेमरी स्पेस लागतो. ठीक आहे, नेक्स्ट कोण आहे? कोण? रोल नंबर फर्स्ट देशपांडे. देशपांडे.
Sir,
हा, question for you. Nerves based curve is rational, uniform, both A and B, and last none of this. Which is correct?
uh, sir, option C.
आता आता आज लेक्चरला होता ना तुम्ही? आता शिकवलं ना
Yes,
कर्व.
sir.
Then which one is correct answer for the nerves curve based on which category? Rational, uniform, both A and B, and none of this. Name itself indicates non-uniform rational. So option is
Yes.
non-uniform, uniform to option A is correct. Okay. So I request to all of you, just don't be present as a lecture. Be attention present. So it will be beneficial to you for the understanding of this subject. Otherwise, you can just attend this lecture, keep the headphone and keep the aside mobile, and just for the presenting purpose you are going to attend this lecture. So that is not good for you. So ultimately you are going to study this semester is online mode. So after the completion of the graduation, you should be understand the what is mean by this, all this whatever we have studied in this pattern, like this curve in CAD CAM C techniques. So you should be answerable at that time, okay, in the industry. So be uh, just listening mode, listen carefully. If you have any doubt, then you can just ask me, okay. So for today's lecture, this is sufficient for you have covered the first two chapters. So if you have any doubt regarding this first two chapter, or in this second chapter, if you unable to understand the what are the geometric transformation, what are the modeling, their problems, their any properties, if you are not understood, then you can just pin me on mail, WhatsApp, or here only, okay. So thank you for this attending this today's lecture. So I am requesting to Yasar, first of all, stop the recording